You are about to learn about the best OCR for your AI agents that you can use to build a state-of-the-art document intelligence pipeline. You can use open source and coding agents to build this out yourself quickly. Stay till the end to get free access to my demo app that you can download and build on top of it. Welcome to Made by Agents. My name is Tobias and let's build it. When you are using AI agents to build anything that has to do with documents, you have a huge problem. And the problem is not the agent itself. The problem is that you need to handle OCR correctly. Imagine you are processing invoices and your agent hallucinates over the invoice total, and then your finance agent approves the wrong amounts. This is still happening even with the best LLMs out there. Most agents choke on real documents because legacy OCR tools were never built for agentic workflows. But today we fix that permanently, so stay tuned. Modern LLMs are great at reasoning, but they are terrible at recovering from broken inputs. So when the OCR layer drops the termination clause or fabricates an invoice total, the agent confidently approves the wrong thing. And if you don't know what OCR stands for, it's optical character recognition. So that means we want to be able to extract the correct text elements from images, documents, PDFs, and so on. And where it can get really tricky is when the document contains very small font and small legal texts or handwritten texts and so on, and the agent is not able to read it correctly and approves the wrong stuff. Or you have documents with a lot of tables and with several columns left to right, reading order, and so on. We are about to fix that with a pipeline of several steps, and the entire thing is completely open source, so you can run this on your own machine, fully private. First step is obviously the input of the documents. Then the second step is a pre-scanning. Before we run the heavier OCR engines, it scans for quality, for deskew, and so on. And then we have the extraction layer where we use specialized OCR models and tools. And then we get the extracted text and we use a structure step to structure this into a specific schema and layout. Then after that, we have an agent reasoner step. So the agent reasons over the structured output and approves it or flags it. And then we have the decision or act step where we do something with the results. Examples for that could be we send it to a CRM or to any other app. We draft replies or emails or whatever, or we send notifications. So the shift is from pure text extraction to document understanding. And I talked about legacy OCR before. There are tools that are out there for many years prior to the development or revolution of AI agents. And then there are more modern tools that use a vision language model that work really great with agents right now. To give you a few examples, Tesseract is a quite well-known library for OCR and text extraction. When you look at their GitHub page, they have close to 75,000 stars and it looks very legit. But when you try this in practice, you see that it's not really that state-of-the-art anymore. But it still has some use cases. Popular tool that uses Tesseract is paperless NGX, and this allows you to search over your entire document stack. And for search functionality, this is still good enough because it doesn't matter if you extract every kind of detail of a table. It's good enough to search and to find documents really, really quickly. Then Easy OCR is another tool that's out there, but hasn't been further developed over the last 2 years. Then we have the vision language models like PaddleOCR, Docling, GLM-OCR, which are much better at understanding the layout, structure, and content in one pass, that are able to extract information from tables and forms and can also output structured content in form of Markdown or JSON for agents. 4 things that are very important for our stack. Number 1 are complex layouts that we need to extract correctly. Then tables and forms, and the reading order is important. Imagine you have 2 columns and you read the first column first till the end and then the second column. So this reading order needs to be extracted correctly as well. And then ideally we get some structured output, for instance in JSON format, that we can pass on to our agent. That's the agent's wishlist. The current open source document stack. We have the VLM engines like PaddleOCR, Docling GLM, Chandra, OCR, marker. This gives us the text. Then we have the structuring engines. They take the OCR output from the VLM engines and turn it into a schema, into a layout. LangExtract is very popular for that, or native Docling. Then there are tools for ETL and chunking like unstructured and Surya. And then we have the legacy tools for baseline, Tesseract, and Easy OCR. So looking at PaddleOCR, this is one of the most popular OCR models right now with 79,000 stars, and they also host their own benchmark. It's developed by a Chinese company Baidu, and you can see here it's able to read Chinese letters and symbols, but also extracting handwritten texts and formulas, basically everything. And a lot of projects are leveraging this model. And here they host their own benchmark where it's obviously on number 1 spot. Not really surprising, but you see here close to it is another Chinese one at GLM-OCR. And then after that we have Gemini 3 Pro, a proprietary model, closed source. And then we have here the Qwen 3 VL models that are also ranking pretty far up, and they are open source. You can host them yourself. So we're about to look at these Qwen 3 models because I don't want to register here, create an account in Chinese to get an API key for this. There's another benchmark. It's called GLM-OCR bench, and here you see Infinity Parser 2 Pro and Chandra OCR 2 and the DOTS MOCR, quite popular here on this benchmark. So that's a possible model that you can use for this step. Another one is Docling, and I tried Docling as well, and it's really fast and works on a standard laptop. It's a very popular solution as well, and it's combining several features, not only text extraction but also structuring the information and various other features. And this uses Rapid OCR under the hood, and Rapid OCR is based on PaddleOCR. So there we are closing the loop. Consider GLM-OCR if you have a bigger machine. It is a bit heavier. And then there are some specialized tools like Chandra tool, which seems to be really good as well. They also have examples here of what it can extract, and on their benchmark it is also on the number 1 or 2 position. They have some examples in their GitHub profile, and you can see here how good it is at extracting these handwritten notes, drawn matrices, and able to format this right away into these formulas. Then DOTS OCR is another one, and Surya and marker are more for layout aware OCR and clean markdown for rec. Now for the structuring step, LangExtract from Google is pretty popular. It's a simple Python library that turns your unstructured text extraction from the LLM into a structured format. And this works with examples. So you provided a few examples, train it on your desired structure and how it should extract information, and then it does it over and over again pretty precisely. And we will see this in action in a moment. So looking at these benchmarks is a good start to find working models, but you need to consider what's running on your hardware, or where do you want to run it, and if this works locally on a small server, or if you want to use an API for this. Depends also on the volume, like how many documents you pushed through your pipeline. and also the type of documents, how much precision you really need. It depends also on the quality of your documents, how much precision do you really need. So let's see this in action, and for that I built a small tool, and this runs partly locally. I have a local example and I have an API example, but also everything is open source, even the API model. You can, in theory, run it on a GPU. So here in my code editor, I'm gonna start this up, and I created a make file for this. So I type make install first of all, and then make dev, and this spins up the backend server and also the frontend server. This is the tool that I built. It's a document approval pipeline, and I built it for two different document types, for invoices and for contracts. And I integrated two different OCR engines just for this demo. One is running locally on my machine. It's Docling. And the other one is Qwen3 visual language that I use via OpenRouter. When you search for this on OpenRouter, you find this one here, and this is the biggest parameter model of this type, and it's quite inexpensive. You can also run this on your own GPU, but to speed this up, I run this via API. Now let's select Docling here and the invoice type, and let's upload an example. Start with a clean invoice, and we can see here the pre-scan step is already completed. This takes only milliseconds, and the DPI, the sharpness, contrast, and brightness, they all pass in this step. Now it was forwarded to the OCR step, which also passed already, and we see here that it extracted all the text and also the table from this invoice, and now it's passing it on to the structuring step via LangExtract. So let's wait for this to complete as well. Now the structuring completed, and the cool thing about this is now when you hover over it, you can see it in the preview where it belongs to. And then we have the decision step, where in this case DeepSeek V4 Flash runs over the structure and compares it to our rule set, and if there's something wrong, then it flags it. So in this case it returned a needs review. The line items have missing quantities and unit prices, amounts cannot be verified per line. So there were some issues. And then we have the compare step here, where we can also run this with both engines. So let's do it. And now we should see the difference when we run this now with Qwen3. So here we have it side by side is the Qwen3 output, and what we can see here is that it also gets the font weight correctly, and this is, for example, strong, and here this as well, and this looks pretty much like Markdown to me. And then we can run this entire thing again if we want. Let's select Qwen3 this time and a contract, and now let's upload a multi-page contract. This pre-scan also passed this time for all these different pages, 7 pages in total. The OCR extraction will take a bit longer now because it's just more text. The OCR step completed now, and we can now see the results page by page. Now the structuring step, where it extracted these relevant fields, and now it's running the agent layer, and it's flagging it with a 95% confidence, so it means it's very confident that it's correct. And the failed rule is auto renew without notice. So the contract auto renews with no termination notice period. Auto renewal clause lacks any notice or opt out window, which is a hard fail. I added this rule in the code base so that it should flag these issues in contracts, and that's exactly what it found here. Everything else is green, but this is like a no-go, so it flags it. Let's try another document, an invoice, and an invoice mismatch in this case. So in this invoice, the subtotal and the text, they don't add up to this invoice total. So the total is wrong in this case. Let's see if it's able to detect this. Pre-scan quality passed again, because the document itself is clean and easy to read. Then the OCR step also passes because it's just extracting the information without reasoning about it. Now the structure step also ran through successfully. And now in the decision step, we get a flag again, failed rule. The total math doesn't equal the subtotal plus the tax. Total amount does not match. So the invoice requires manual correction or clarification of the total calculation. So it fails in this case. Try another example, and this time a really low resolution scan of an invoice. And now you can see that in the pre-scan step, it's warning already. The sharpness is very low. It's possibly blurry. But Qwen3 will be still able, surprisingly, to extract information from this because it's just pretty powerful. So OpenRouter seems to have some issues right now. Let's try this again with Docling, our local model. And you can see here why it's really nice to have something locally running, because you see here after 4 seconds, we already get a response. But Docling is not good enough to extract really anything from it. We will get, yeah, 0% confidence rating. It's not able to extract anything from it. Just the pre-scan quality is too low. Last but not least, one more example, a degraded image running Docling again, but it's able to extract more from that. It's not too bad. Just the contrast is very low on this one. And it's tilted by 8 degrees, but that's not an issue. We can tilt it back and we get a 50% confidence rating. Just the total contract value is above our limit that we set in our code base, in our variables. So we set the limit out to 10,000 and this is 350,000. And again, it warns about the pre-scan quality and also wasn't able to extract enough. Yeah, that's the demo app. And I also added a grid view here, and from here you can tap back into the results or delete one or all of them if you like. So here the architecture, again, we have this pre-scan step. Then stage 2 is the extraction layer, where I showed you Docling and Qwen3. This can run locally or in the cloud. Then we have LangExtract, which is also running locally. And then stage 3 is the decision step, where we have the AI agent that's reasoning and then approving or flagging the result. And then after that, we can forward it to more steps. And here you can see just the difference of the legacy OCR. If we use something like Tesseract, we would get something like this as the output compared to the stage 2 structured output that we get here. And now you can understand why this here is much easier for an agent to understand than this here. So the question right now is just when to use which tool. And to help you answer that, I have a slide for that here as well. So when you want to build a search-heavy application, then you can use Tesseract or unstructured. That's really good for high volume. It is much faster in scanning, uses less compute. For complex contracts and invoices and legal documents where the accuracy is very important, you can use something like Docling or Qwen3 or PaddleOCR or GLM-OCR, one of the top OCR models that I just showed you. And then you can combine this with LangExtract if you want to get these exact fields with citations where it came from and a schema. And for RAG application, retrieval augmented generation, you don't need this necessarily. You can use Marker or Surya as well. That's it. Your agents are now document native. The links are in the description. The link to the demo app is also in the description. You can find this on GitHub. Thanks for watching. And if you want to learn how you can build an AI multimodal knowledge base that works not only with text, but also with images, videos, and documents, then check out this video here.